In 1863, a Confederate admiral sailed through an ocean that glowed like a phantom sea, its light stretching to the horizon. The whole sea was several shades lighter than the sky, he wrote, awestruck. For centuries, these milky seas have haunted sailors, defying explanation. Are they nature's magic, a cosmic signal, or something stranger? Welcome to Oddities Uncovered, where we plunge into the world's strangest mysteries. This is The Ghostly Glows, a 50-minute journey into the bioluminescent seas that light up the unknown. Hit subscribe and ring the bell to dive in with us. Beneath the ocean surface lies a world where darkness reigns, yet life finds a way to shine. Bioluminescence, the ability of living organisms to produce light, transforms the sea into a canvas of ghostly glows. From tiny plankton to deep-sea monsters, these creatures create a spectacle that feels like magic. This jar holds Dinoflagellates, microscopic algae that light up when disturbed. But they're just the beginning. In the ocean, bioluminescence is everywhere. Jellyfish, squid, even bacteria. It's a language of light spoken in the dark. Bioluminescence is a chemical marvel. A molecule called luciferin reacts with oxygen, catalyzed by the enzyme luciferase, producing light with almost no heat, a cold light. In the ocean, this glow is usually blue-green, the color that travels farthest through water, per a 2023 National Geographic article. It's like nature's glow stick, but infinitely more complex. These lights aren't just science, they're a spark of wonder. They remind us that even in the deepest, darkest places, life creates beauty, a beacon of hope in the abyss. The ocean's glow has captivated humanity for centuries. In 1832, Charles Darwin, aboard the HMS Beagle, marveled at a wonderful spectacle, waves sparkling with pale light. He attributed it to tiny crustaceans, but the true scale of bioluminescent seas eluded him. Decades later, in 1863, Confederate Admiral Raphael Semmes described a sea that glowed like a phantom, stretching to the horizon. His account, one of the earliest reliable records of a Milky Sea, became a cornerstone for science, per a 2022 Scientific American article. These vast glowing expanses, sometimes covering hundreds of square miles, were more than a sailor's tale. They were a mystery begging to be solved. Milky Seas are likely caused by massive blooms of bioluminescent bacteria such as Vibrio harveyi. These bacteria create a continuous glow that can last weeks, often in nutrient-rich, calm waters like the Indian Ocean. But their triggers, possibly lunar cycles or ocean currents, remain elusive. A 2025 CNN report notes that Milky Seas had been sighted over 400 times since the 17th century, yet only a dozen have been studied closely. Their rarity makes each sighting a scientific treasure. For those who saw these seas, the glow was a moment of awe, a fleeting glimpse into the ocean's soul. It's a reminder that some mysteries are meant to stir our hearts as much as our minds. Bioluminescence is a chemical symphony. Inside organisms like plankton or jellyfish, luciferin, a light-emitting molecule, reacts with oxygen guided by the enzyme luciferase. The result? A burst of cold light, efficient and heatless, per a 2023 NOAA Ocean Exploration Fact Sheet. It's like a natural glow stick, but alive. In the ocean, 80% of creatures between 200 and 1,000 meters deep are bioluminescent, using light to hunt, hide, or communicate. From the anglerfish's glowing lure to the vampire squid's sparkling arms, it's a language of survival. Take the deep-sea shrimp Heterocarpus encephalus, which can vomit light from glands near its mouth to distract predators. Her 2021 Deep Ocean Education, or the brittle star, which uses bioluminescence as a warning signal. These adaptations show how light shapes life in the abyss. Some creatures like anglerfish host bioluminescent bacteria in special organs, a symbiotic relationship where the fish provides nutrients and the bacteria provide light. This partnership, per a 2021 Yale E360 interview with Edith Widder, is a testament to nature's ingenuity. These lights are more than survival tools. They're a testament to life's creativity, a dance of chemistry that illuminates the dark. Bioluminescence isn't just a natural wonder, it's a muse. In 2012, artist Shi Huang transformed the Smithsonian's National Museum of Natural History with installations that glowed like deep-sea creatures, per a 2018 Smithsonian Ocean article. His work blurred the line between art and science, inviting us to see the ocean's light anew. Across cultures, bioluminescence has sparked stories. In Japan, ancient poetry speaks of sea fire, while sailors worldwide saw glowing waters as omens. These tales weave a tapestry of wonder, connecting us to the sea's mysteries. In science, bioluminescence has revolutionized research. In 1962, Osamu Shimomura isolated green fluorescent protein, GFP, from the jellyfish Equirrea victoria, earning a 2008 Nobel Prize, per a 2016 Hakai magazine. GFP allows scientists to track proteins in living cells, aiding cancer research and beyond. GFP's discovery came from studying bioluminescent jellyfish, showing how ocean mysteries drive innovation. Today it's used in everything from brain mapping to environmental monitoring, per a 2023 Nature article. From ancient myths to modern labs, bioluminescence bridges art and science, reminding us that curiosity can light up the world. As we marvel at these glowing seas, we face a stark reality. They're under threat. Light pollution, chemical runoff, and climate change are dimming the ocean's light. In Puerto Rico's Mosquito Bay, once a beacon of bioluminescence, sedimentation and artificial lights have weakened the glow, per a 2023 National Geographic report. These threats don't just harm bioluminescent organisms, they disrupt entire ecosystems. Plankton are food for countless marine species, and their loss ripples through the food chain. But there's hope. Light pollution confuses marine life, while chemical runoff kills delicate plankton. Rising ocean temperatures lead to climate change, altered nutrient cycles that fuel bacterial blooms, per a 2021 Yale E360 article. Protecting these ecosystems means tackling these global challenges. In Vieques, Puerto Rico, community-led efforts have reduced light pollution by 30% since 2020, restoring Mosquito Bay's glow, per a 2024 local conservation report. These small victories show that change is possible. Every glowing wave is a call to action. By protecting these seas, we preserve not just beauty, but the balance of life itself. For centuries, Milky seas were the stuff of legend, ghostly glows that defied explanation. But in 2025, a team of oceanographers changed everything. They compiled a database of over 400 Milky Sea sightings, from 17th century logs to modern satellite data, for a CNN report. This treasure trove is unlocking the ocean's greatest mystery, allowing scientists to predict when and where these events might occur. Picture this: a ship sailing through a sea that glows like a galaxy, guided by data that was once a sailor's dream. This breakthrough isn't just science. It's a testament to human curiosity, a light in the dark that shows us what's possible when we dare to explore. The ghostly glows are more than a mystery. They're a call to wonder, to protect, to question. They remind us that the ocean, like the universe, is alive with secrets waiting to be uncovered. Have you ever seen bioluminescence in nature? Share your story in the comments and vote in our poll. What causes Milky Seas? A. Bacterial blooms. B. Lunar cycles. C. Unknown organisms. D. Something else. Share this video to... That's the ghostly glows, a plunge into the ocean's luminous mysteries. Oddities Uncovered is all about chasing the strange and wondrous, from glowing seas to vanished villages. If this journey stirred your curiosity, like, share, and subscribe for more. Next, we're exploring Teaser, the vanishing village, a town that disappeared overnight. Stay curious, keep exploring, and let's uncover the unknown together.